Okay, welcome back. We just started talking about the using a function to fill in something. This is actually pretty cool, but that way you, the human, don't ever have to record, what's the order date and things like that. It'll automatically just fill it in for you. Isn't that pretty cool? Okay, so I'm going to go and throw in a couple more things in here. I'm going to throw in age, and it's going to be an integer, and I'm going to make it not default. Not null for some reason. Okay. I need to put a comma there. Okay, cool. So now we're going to do some data constraints. They're called, on page 341. So this constraint was for creating primary keys and foreign keys. Now we're going to do one for data. And so what I'm going to do is I'm going to go in here and I'm going to say constraint. It needs to have a name. So I'm going to call this one age, and I'm going to say CK. That's just my thing. And this is a check constraint. Okay. Now, what happens here is just as if this was like a where clause. Okay. So, for example, I could basically say in parentheses, I would say age is greater than 0, and age less than 140, like that. Okay, so I've created a constraint. Now there are some versions of databases that will allow you to do a check constraint on the same line. Don't do that. I like the honest-to-God explicit constraint command. Okay, so if I like it, that's what I'm expecting. Let's do the one for state, for example. I'm going to do state CK check. And you know how you can go in here and use practically anything from a where clause, right? So I can say, I'm going to put square brackets in there so I don't go crazy. State in, remember the in command? So I'll only accept Texas and Louisiana and Oklahoma. That's it. Okay, so these are examples of check constraints. So this is a domain constraint. All it is using the in keyword. It's nothing fancy here. So a domain constraint. Okay. This is a range constraint. Okay, right? I could have said age between. That would have worked. All right. Is that kind of sort of making sense, guys? Okay. Let's continue. All of these explicit constraints require a name because I might want to talk to it later. Okay. And so the constraint looks just like a where clause without the where keyword. And yes, the parentheses are required. And I will tell you that something kind of weird is MySQL doesn't support the check constraint, which is kind of weird. I would have thought it would. So it's a very handy tool. Remember, the whole point of all this stuff is to prevent you from putting garbage in the database. Remember, that's the whole point of all this. You're trying to build something so that you can't go wrong. You can't put a -4 in the age. You can't put 400 as an age. You can't have a state that's not where we aren't licensed to do business. So this is what it's all about. It's about creating these rules that you apply to the database so people can't put crap in the database. Good. Okay. All right. So they basically sort of have a summary here. Here's an example where they put the check constraint and they said nationality in. Okay. So this is a range constraint. Here's a weird one that I thought was pretty cool. I never thought about this. Where the date of birth has to be less than the date deceased. Yeah, that makes sense. You can't have them backwards. The valid year of birth. So they're showing numeric, and so they're saying, okay, you can't have a year of birth that starts with a 3 or a 0. It's going to have to be a 1 or a 2. Kind of makes sense. So that's really super duper stuff, right? And then down here, pretty straightforward. Okay, so let's just do a summary. Stop for just a minute and talk about constraint summaries. So the column constraints would be null and not null. Okay. The explicit ones would be a primary key constraint. a foreign key constraint, a unique constraint, and then a check constraint, okay? Things that are not on the list are identity and default, because that's kind of sort of not really constraints. Yeah, it falls into the same discussion as a constraint, but you can't literally say that a default is a constraint. I mean, just from the English language, that doesn't make any sense. But okay, but they are. So, null and not null, primary, foreign, unique, check, and then the two oddball things, which is identity and default. Okay, so I'm going to skip a bit, and we're going to go to page 346, where we start altering a table. Okay, so I'm going to go back to my guy. I'm not going to execute this because it's just junk. So I do have a student table, okay? And what I want to do is, after it's built, let's make sure it is built, because I can't remember if I did it or not. Yay, there it is. Okay, so I want to alter this table to add another column. Well, I mean, I guess I could go in here and whack this thing, but what if it had data in it? I don't want to do that. So we're going to learn yet another command. So right now hey, let's keep count. The select command, create command. Woohoo! We got two of them. All right, we're getting ready to learn a third one, okay? And it's going to be the alter command. So alter will allow me to go in here and say, alter table student, okay? And this one's kind of weird because for some reason I don't need a parentheses. I don't ever get this. I'm going to do it on 2 lines, again, just because. And I'm going to say, add, I don't know, zodiac sign or some goofy thing like that. And let's make it an inchar 10 or something. I don't know how many letters there are in there. And I'm going to make it null, okay? So what this basically means is I'm going to go to the student table. I'm going to add one. By the way, it always adds to the bottom. You don't get the choice to like insert it into the 3rd spot or the 4th spot. It always goes to the bottom. Okay, I'm going to run this to make sure it works. And ta-da! Okay, so if I go here to my student guy and I say, you know, select, I don't have any data, but this will at least show me the things. So zodiac sign showed up at the bottom, okay? Which means it's at the end, which is exactly what I had in mind, okay? Cool. All right, that kind of sort of makes sense. Good. So I can alter, by the way, when you're using the alter thing, this is one of the few places where you don't tell it what you're adding. You would think every other time we do an alter, if we want to drop something, we have to tell it, oh, I'm dropping a column. But when you're adding, you don't have to tell it the column. The keyword column here, I don't get that. I don't know why that's the case, but it just is. So the add defaults to a column. Okay. None of the other add things, alter commands do that. So I could go in here and do a drop. Hey, I guess I'm going to go ahead and build this guy. I don't think I made any errors in there, did I? Good. All right. So I'm going to go in here and whack some stuff. Okay, so I'm going to do alter table temp. Okay. And so what do you think I'm going to do? Let's just drop one of those constraints. So I have to tell it that I'm dropping a constraint. And I'm going to drop the state CK. What do you think? Let's try it. Now do you understand why every one of these explicit constraints needs a name? If you had done it the other way, for example, I mentioned that there is a technique where you could actually put this on the same line as this guy. But if you did that, you won't be able to talk to it. Okay, so don't do that. Always use the explicit one. So I can drop a constraint. Maybe I can even go and add a constraint. Okay, let's try that. So alter table temp, add constraint. In fact, I'm going to add that and put that guy back. Call it state2ck. And it's going to be a check constraint. And I'm just going to say age is less than 140. Okay? I'm going to do that. Oh! Add constraint. Oh, it helps if you spell it right. Let's try that again. Oh yeah, it works much better when you spell it right. Okay. Okay, so next we're going to do an alter column thing. So I'm going to go here and I'm going to say alter table student. And I discovered that the zodiac sign doesn't have the right data type. So I'm going to go in here and say alter column. The column keyword is required. The name of the column. And I'm going to change this to in varchar, I don't know, 15. And I could change null to not null, but I'm going to leave that alone. That's how you change the other parts. Now, you can't change the name, kinda, because you have to call it by its name. I mean, you can create a new column and then get rid of the old one, but there's no rename. Okay, so I'm going to go ahead and do this. And so, ta-da, I've changed the data type. Okay, kind of makes sense? Okay. So I think we pretty much all got all of the alter stuff. So right now we've learned the select command, we've learned the create command, and now we learned the alter command. And alter will allow me to add columns, and add a constraint, delete a constraint, change column properties, all sorts of things like that. The next thing we're going to learn is the drop and truncate commands. So I'm going to go here and say, I want to drop table major, okay? So what did we say when we built the referential integrity? What did we tell the machine for the on-delete function? Because this essentially is going to do an on-delete. It's going to come up saying, I'm sorry, I can't do that because it's got a referential integrity. Now, this is not an error. This is a rule. You built a rule to protect you from doing something stupid. So don't look at this and go, oh, man, something went wrong. No, everything worked exactly as designed. You put that control in place to prevent you from doing something stupid. So drop makes the entire table go away. Just this table over here just vanishes. Everything. Now let's talk about truncate. Truncate is very, very similar to that. Truncate table major. Except it's going to leave all the stuff intact. For example, it's still going to have the columns. It's still going to have the primary keys and the identity and the, you know, all the foreign keys and all the rest of that defaults, everything. In other words, the structure is going to remain the same. It's like a super duper delete where like you just delete all the rows. Okay? So, hey, if I ask you in a test question, what's the difference between drop and truncate, you'd be able to tell me, wouldn't you? Hey, is this going to work? Can I? Because remember, truncate just makes the table, all the rows go away. I don't actually have any rows, but the machine doesn't know that. He goes, no, man, can't do it. You can't do a truncate because of referential integrity. And once again, this is not an error. This is you protecting yourself. Okay, man, we've learned 2 more commands. We've learned the drop command, the truncate command. Woohoo! All right, the next thing we're going to talk about is indexes. Now, we're not actually going to create an index, okay? I'm just telling you, we're going to wait till like chapter 10 to do that. But we're going to talk about them. And that's kind of important. All right, so indexes are designed to make the database run faster. It pre-sorts. Let's say you had an Excel spreadsheet. And sometimes you need column 2 sorted. And sometimes you need column 4 sorted. So, you know, an Excel spreadsheet, you can't really, I mean, you would basically have to have like 2 tabs. One of them sorted on column 2, another one sorted on column 4, because you can't sort them both at the same time, right? I mean, column 2 is the only column you wanted sorted, and then later on, column 4 is the only column you wanted sorted. Okay, so that's what indexes are. Indexes do a sort behind the scenes, and you can have lots of them. I can have a sort on column 2, a sort on column 4. And it's designed so that whenever it speeds up a where clause, whenever you have a where clause, the machine has to go through, let's say it was not sorted, and you're hunting for, a name, you're hunting for Fred, and it would go through and go, well, start at the beginning. It would have no choice but to look through every single one hunting for Fred because it's got no other way of doing it. If it was sorted, it would say, well, once I get to the F's and there's no Fred, there's no need for me to go any further. So you see how an index could speed things up? Okay. Hey, we're coming up on the 15-minute mark. Let's continue this discussion in just a few.